The purpose of this video is to show you how to extract data from the IOLab software and how to analyze it in Microsoft Excel. So here I have data from sliding the IOLab device down an incline, and I have three graphs here. I have the wheel position, the wheel velocity, and the wheel acceleration. And what I want to do is download the data for the velocity, find the slope, and possibly compare that with the acceleration of the wheel. So to first get the data from here, I can go down here, click on this, and say export to CSV. And then up in the corner, it gives me the name of the file. If I click on it, nothing happens. So I actually didn't pay attention to the name of the file, so I'll just look up wheel because I know that it had the word wheel in it. So I click on it, and here is the Excel file. So now you'll see a whole bunch of numbers, and it's quite intimidating. I have no idea what all these numbers are, so let's try to figure that out. The only thing that I know here is that this column D, is time because it has time written here, but I don't know what all of the other things are. Index is probably the number of data points, so that's just a sequential line of numbers, so I'm going to ignore that. But I don't know, again, which of these columns will be of interest to me. So let's go back to the IOLab software, and let's see here. If I go down to this point somewhere, one time is 1.13 seconds, I should have a velocity of negative 0.12 meters per second. So I'm going to go back to the Excel spreadsheet. I will try to find time is 1.13 seconds, and then see in which of the columns I will see the value negative 0.12 meters per second. So let's go there. And time was 1.13, so that is over here. And now, where do I see negative 0.12? Over there. So that means that this is my time column, this is my velocity column. So those are the columns that I'm interested in. I'm going to copy them and bring them into a different spreadsheet here. So for the first few milliseconds, hundreds of seconds, I have no data for the velocity. So I'm going to go back to where I first saw the slope of the velocity change, and that was at around 1.13. So I'm going to delete everything before that. So I select it all and then right click and hit delete. And now I want to see how far down I should go. So about this point at 2.16 seconds. So let's go back to the Excel spreadsheet, find 2.16 seconds. So that is here. I'm going to get rid of everything beyond that point. So I'll delete all of that. So now I have just this portion of data that I want to find the slope for. So going back here, I'm going to select these two columns. I'll go to Insert, and here find a scatter plot. I don't want to connect the dots, so that is my scatter plot. Now I'm going to point at one of these points. They're all very close together. Right click and go to Add Trendline. And for the trend line, I see that it's a linear fit, and that's what I'm interested in. I can display the equation on the chart. So here is my equation. It gives me the slope and the y-intercept. And I'm going to change the line color because both my data points and my color are blue. So let's make this red. So here I see the slope of the line superimposed on my scatter plot. Now, I have the slope, but I don't have the uncertainty in the slope. So what I can do next is select here 2 columns and 5 rows. And with them selected, I'm going to go here to the formula bar and use a function line statistics. So that is, we enter equals LINEST, again for line statistics. And then I want the column Y. So column Y goes from B1 to B104. So I'll do B1 colon B104. Then I'll have to enter the range for column A for the X axis, so that would be A1 through A104 again. Then I will put true, true, comma, true, close parenthesis, and before hitting enter, or instead of hitting enter, I'm going to hit Control Shift Enter, and that populates all of these cells that I had selected in the first place. So now, what are these numbers? Well, if you look at this first one here, negative 0.997, and if we look at the equation for that slope, we notice that this negative 0.997 is actually the slope. So we already had that value, but that's a good thing to have in this table. Then if I compare, again, the equation with the data points that I have there, I noticed that the 0.976 is this value, so that is the y-intercept. And this quantity is what we're really interested in. That is the uncertainty in the slope. So whenever you plot a graph, you will want to know what the slope is and also the uncertainty in the slope. Now, there's a whole bunch of other things here. That value is the correlation coefficient, how well the fit worked, and it's almost perfect, it's almost 1. So that was the r-squared value. And then this is the regression of sum of squares. There's some things that we're not going to be really discussing or not interested in. We're not going to be interested in a whole bunch of these values. But another thing that might be important is the y-intercept, which we already know, and this here is the uncertainty in the y-intercept. So again, slope, uncertainty in the slope, y-intercept, and the uncertainty in the intercept, and then this is the r-squared value, or how well the fit worked.